Okay, let's take a look at tutorial 3, question 3. So we have an investment fund in which you plan to invest some money, has some capital, 200 million. So we have some stocks. We have the weights of the investments, 60 million. I guess there's 20 million, 50 million, 30 and 40 million. We have some beta values and some risks. The current risk-free rate is 7%. Risk-free rate here. Whereas market returns have the following estimated probability distribution. Okay, so we have some various potential events in the market that's affecting the returns, maybe a recession or a booming economy, or many different possibilities. For simplicity, there's 5 possible outcomes affecting market returns, each of them in this distribution. Part A, write down the equation of the security market line, draw it up, and just the usual stuff, label everything as clear as possible. Okay, so let's begin with that. Part A. So the security market line, we know this is the following. Okay, so it's the line defined by this equation. There's another equation. I'm not sure if we're going to need it. Let's write it just in case. It's connected to the beta value being the constant of proportionality between the variance and the covariance. Okay, so we're going to be working with this one on the left. So we need to calculate a few things. We need the market return. So let's do that first. Okay, so we have a market of 5 stocks. We have some probability distributions. Okay, so the expected market return using the probability distribution just here is, well, the 10% chance the market will give a return of 5%, a 20% chance, or 0.2 of using probability, of a 7% return. So if we do the weighted average, the expected market return, okay, some number crunching will give you 11%. Okay, we're almost ready to do that. Yep, we got the risk-free rate. We're ready to build that security market line. But this question has a few more requirements on the other page. So whilst we're here, let's calculate the risk. We're going to need it later. So the market risk, so we're going to calculate the variance. So we calculate the deviations. So the first deviation is 5, take away 11. We square them and take the weighted average. This is the definition of the variance. We sum over all states. The usual definition of the variance, which will give the market risk of, I make it 0.0012. Okay, we got that out of the way. Let's calculate this security market line. Okay, so what is that? Well, it is the expected returns on an asset versus the beta values. Okay, and we got the equation just by here. So drop all those numbers in. We get the expected return on asset I. Okay, take the RF over, which I believe was 7%. Okay, plus the, what is it? Here it's the market return, take away 7, so that's 4% of the beta value. Okay, so this is the security market line. And this is quite easy to sketch. Importantly, we have the beta factors going across the bottom and the expected returns on the y-axis, and it's a straight line graph. Okay, so that's requirement A. That's the SML. Let's take a look at some of the other requirements on the next page. Calculate the beta of the portfolio. Okay, let's do that next. So the beta on this portfolio, well, if we take a look at the information that we have on betas, what do we have? We see here we got some beta values for each of the stocks, the individual betas, and we've actually got the weightings here. So we got 200 invested. So these are the weights. Okay, so we can use this information to calculate the beta of the portfolio. So the equation we're looking for, the beta of the portfolio is the weighted betas, the weighted average of the betas, 5 states. So we have 5 terms. Okay, the first asset has 60 million invested out of the 200 million, and the first asset has beta 1.46, and repeat this on each of the terms. There's only 5 terms. The final term is 40 million invested out of the 200. The beta of the final stock is 0.82. So if we add all those up, the beta on the portfolio is 1.0575. Okay, let's calculate the job. And that completes part B. Okay, how about part C? Calculate the systematic risk and specific risks of the portfolio. So systematic and unsystematic risks. Standard equations. Systematic risk is the beta value squared times the portfolio the market portfolio variance, which I make as 0.001342. 134, let's cut off the 2. There you go, 42. Okay, that completes the systematic risk. Part D. Calculate the expected rate of return of the portfolio and its price. Okay, so the expected rate of return of the portfolio using the security market line in this case. Okay, so we're going to use this equation, standard equation. This tells us the expected return on the portfolio is the beta of the portfolio times the excess market return compared to the risk-free plus the risk-free. Drop all those numbers in. I make that 11.23%. Okay, all of the numbers are there, just drop them into the calculator. Okay, that completes part D. How about part, the next part, is there any more? I believe so. Yeah, part E. It's the last part of this question. Let's take a read. Suppose you have the possibility of purchasing a new stock with an expected return of 15% and estimated beta of 1.8. The investment needed is 40 million. So the investment needed is 40 million. Should the new stock be purchased? At what expected rate of return should the fund be indifferent to purchasing the stock? Okay, so we need to build the some numbers from the model. So according to the model, CAPM model, or CAPM I should say, the expected return on this asset is 1.8, that's the beta value, 0.04 excess return plus the risk-free rate. So we should get an expected return of 14.2%, and actually the question suggests that we have a return of 15%. The model is saying should get 14%, so the asset is underpriced. At 40 million. Okay, 40 million, it should be producing about 14.2%. Actually, again, a lot more than that. So it's underpriced. And we can quantify this if we look at the expected return. So everything we get in our hand. And we look at the rate of return for this asset. So P is the price, what we pay for it, 40 million. Well, according to the CAPM model, this expected return, well, the expected rate of return, which contains the expected return, should follow the CAPM model. So some simple rearrangements. how much should we have in our hand after using the model. After some number crunching, you can see that the expected return on the 40 million investment is 45.68. But if you take the 40 million and you build in the 15% return, you get 46. Okay, so we're just quantifying the difference between the model, what we should get in terms of expected return in our hand, and the assumptions made from the asset. We can see there's a difference of £0.32 million, which is an estimate for how much it is undervalued.